Today we're talking about equations and expressions, both of which are very much related. There is one key difference between the two, and we're going to talk about what those differences are. But first, we're going to talk about some basics that you will encounter, some vocabulary, so that way we're all on the same page with our terminology. First thing we want to talk about is what is a variable. And what a variable is a placeholder for some value. Essentially, it's holding the spot for a number that we haven't been told yet or that we have to discover. The thing about a variable is that it can vary or change in value, hence variable. Like a variable, just like in science class, is the thing that you change, just like a constant is the thing that stays the same in your experiment. A variable is the thing that you're going to change, and a variable in a math expression or equation can vary or change in whatever its value is. Here are some examples of some variables, some located within what are called expressions. But as you can see, the M is a variable, the D is a variable, the Q is a variable, and the F is a variable. Now, if you pay attention, all of these examples use letters as variables. We usually use letters for a couple reasons, one of which is the fact that they're easy to draw. They can quickly be replicated. But the other reason is that most people know what those variables are. They know what a letter is. So we don't have to waste our time explaining that, oh, no, what I was actually drawing was a snowman. And you just couldn't tell that, that was a snowman. You thought it was something. And you got to argue. Plus, replicating a snowman over and over again, snowman squared plus 5 becomes a little bit more difficult and it takes up too much time. Very similar, but slightly different is the definition of an unknown. An unknown. Once again, it's a placeholder for some value, so it's the exact same definition, but the difference is that an unknown cannot change in value. Now, that might sound confusing to you, but here are some examples where we still have what would be variables, but these have one set value. In this example, M could be anything. It could be 5, 10, 30. It could be 2.2, so we can introduce the decimals. It could be -7. It could be a negative number. It could be irrational numbers. It could be square root of 5. But down here, M could not be the square root of 5. M could be 9, and that's it. The only thing that M could be is 9, because if I plugged in anything other than 9, I would not get the correct value. So again, 9 plus 1 equals 10, because 10 equals 10. That's the only value that will work. So in this situation, it is holding the place for some value, but that value is 9, and it's nothing else. This M could be more than one thing. In this situation, again, an unknown holds the place for one value, sometimes two, but those are situations you will not find yourself in this year. An expression, very important definition for us. An expression is any combination or grouping of variables and or numbers. Don't have to have both, but you have to have one of the two with at least one math operation. Now, this is the key of the whole thing. If you don't have a math operation, you don't have an expression. You could have just variables and no numbers. You could have just numbers and no variables. But if you don't have a math operation, you don't have an expression. Here are some expressions. These are expressions because they all have a math operation. Addition, subtraction, multiplication and addition, squaring and addition. This one looks like it doesn't, but it does. It's got multiplication, another multiplication, and exponents. This one has multiplication and division. So if you notice in all of these, they all contain variables, but they don't have to. It could be just 5 or 5 squared. That's a math operation, therefore that's an expression. It could be something even more obvious, like 5 plus 2. This does not contain variables, but it is an expression because it has at least one math operation. It could have no numbers. It could have just variables. For example, W plus M. That is an expression. It's an expression because it contains a math operation. Here's another expression that students often get wrong. X, Y. It's got only variables, doesn't have numbers, that's okay, but it does have a math operation, which is, of course, the multiplication between the two. If you don't have a math operation, you don't have an expression. This is just the number 7. That's not an expression. You have to have some sort of expression, some sort of math operation in order for it to be an expression. Now, An equation, the definition I used to have was an equation is an expression with an equal sign somewhere in the middle. But I actually don't like this. I don't like this definition anymore because a couple things. One, an expression implies that an equation has to have a math operation, and it doesn't. 5 equals 5 is an equation because it's true, but it doesn't have any math operations. So I don't like that part of it. And somewhere in the middle, when I read somewhere in the middle, it sometimes confuses students. They go like, "What do you mean somewhere in the middle?" Like if it was 2 plus 5 equals 7, that equal sign's not in the middle. When I say in the middle, I mean not dangling off the edge. You guys know how I feel about doing something like that. That's not an equation because that's an incomplete sentence. So I'd like to call an equation, instead, I'd like to call an equation a true math sentence with an equal sign. So it has to be true, has to have an equal sign. Again, not dangling off the edge, sort of somewhere in the middle, but it has to be a true math sentence. Here are some examples of equations. Notice that there are a lot of unknowns. Sometimes there are variables in equations, but bottom line is if it has an equal sign, it is probably an equation unless it's not true. This, 2 plus 3 equals 6, this is not an equation because it's not true. So it has to be true. What you're doing next is you are determining if these are equations, expressions, or neither. When we focus in and go a little bit deeper with algebraic expressions and the different parts of an algebraic expression, we introduce more vocabulary. And so we're going to have to determine what we have when we look at different aspects of an expression. So the first thing we want to review is what an expression is. An expression, as we just talked about, is any combination of numbers and or variables with at least one math operation. Here are some examples of expressions, all of which contain a math operation. Again, this has addition and multiplication. This has multiplication squaring, multiplication, addition, subtraction, multiplication, addition. You can see in this one it has addition, but they all have some sort of math operation. Two of these contain variables. These two examples contain variables. These two examples do not contain variables. They're still expressions, but if they don't contain a variable and they're just numbers, this is called an arithmetic, or more commonly called for you guys, numerical expression, because it's only numbers. If it contains a variable, that is what is called an algebraic expression. An algebraic expression is an expression that has to have variables. Could it have numbers? Yes. Does it have to have numbers? No. But if it doesn't have an expression, a math operation, and variables, it's not an algebraic expression. Here are some examples of algebraic expressions. Again, note this one, it doesn't have numbers, but it does have variables. So if it contains a variable, even just one, it's an algebraic expression. We usually use letters, as we talked about, because letters are easier to replicate. Now let's break down this particular expression. When you look at an expression and you see a plus sign or a minus sign, sometimes equal signs or is greater than or is less than or is less than or equal to, sometimes those symbols also. But for expression purposes, if you see a plus sign or a minus sign, and that's it, they separate the expression into parts, each of which is called a term. Once again, every time you say a plus sign or a minus sign, here's a minus sign, here's a plus sign, here's a plus sign, here's a minus sign. It's now split this expression into parts. Multiplication symbols, like 5 times r, hold terms together. 5xy times 3 is all multiplication. Therefore, this is just one term. But when terms are separated by plus signs or minus signs, this 3r, this negative 5r, because you might say, well, that's subtraction. Well, if you do keep, change, it's a negative 5r. This 2y squared, this 9, and this negative 1. Again, you might say it's a positive 1. No, keep, change. There are 5 terms in this expression, each of which is a term. There are 5 terms. The terms are, if I wanted to list them, 3r is a term. Negative 5r is a term. Do you need to put that negative sign? Yes, you do. 2y squared is a term. How come we didn't put plus 2y? Well, it's implied that it's a positive because there's no number out front. 9 is a term, and negative 1 is a term. Again, you might say it's not a negative 1, subtract 1. Once again, keep, change. It's a plus negative 1. So it's a negative 1. There are 5 terms. Breaking down those terms, if there is a term that does not contain a variable, in other words, it's just a number like those two guys, those are called constants. Just like in science class, they're called constants because they're constantly the same number. There's no variable around them to change them. It's just the number -1 and the number 9. So those are constants. There are 2 constants in this expression. There are plenty of variables, but 2 constants. Constants are their own terms. They don't multiply with a variable. If it does multiply with a variable, so if there's a term that does contain a variable, that number out front, in this case, the 3, the -5, yes, that's a -5, keep, change, and the 2 are called coefficients. So multiply coefficient. You might think of it like a co-worker, right? Like co-workers work with someone, so they work together. The 3 works with the r, the -5 works with this r, the 2 works with the y squared. In this situation, there are 3 coefficients. Here's a nice example. How many terms are there? I'll let you think for a second. There are 1, 2, 3, 4 terms. I see 1 plus sign, 1 minus sign, 1 plus sign. So that splits it into the 1, 2, 3, 4. In this particular one, there are 3 coefficients. 2 is a coefficient. 8 is a coefficient. And now you're probably looking for the other coefficient. You're guessing it's -4. It's not. The other coefficient is the 1 in front of the p because it's 1 times p. That's the multiplicative identity. So the coefficients in this example are 2, 8, and 1. Do you have to say 1? Yeah, on the test, you're responsible for identifying the coefficients. In this case, if you don't write the 1, you get it wrong. What are the constants in this example? Constants in this example, -4. If you put the constant as just regular 4, would you lose points? Yes, because the constant is -4. For these, please identify the parts. And then you can do the same for this one. Do the work on this one. You're only responsible for choosing 2. Show your work. For this one, again, choose 2. Show your work. And then this last one, we want to see if I plugged in 8 right here, would we have a true equation? Let me give you another example. I'll give you a very simple example. W plus 6 equals 14. Let me plug in 8 for W. 8 plus 6 equals 14. 8 plus 6, 14 equals 14. Hooray! Let's try another example. 2W equals 10. Well, we're plugging in for W. 8. 2 times use parentheses 8 equals 10. 16 equals 10? No, not true. Doesn't make it true. Doesn't make it true. Do the same for 8 and for 9. When we say we're translating from English to math or terminology to math, what we mean is we're going to take words in the English language or whatever language and turn them into math symbols. Just like translating from one language to another language, where we want to say the exact same thing the exact same way. If we said a question in English and then we answered the question in Spanish, that wouldn't be translating, that would be answering the question. Whenever we say in English, we say the exact same thing in Spanish or French or Swahili or whatever you're translating to. But the common mistake for students when they translate for math is they try to answer the question. Don't answer it, just write whatever the question was. One of the bigger tips that I can always give students is first things first is you should see if there's the word is or equals or something like that. You see the word is or equals, you should immediately circle it because that implies that it's an equation. You could write that down and then write is 34. So I know that the first example is an equation. From there, you're finding the words and the numbers that just allow us to translate exactly. Some keywords for addition plus some more than increase by in all. Sum is one of the keywords. Subtraction is tricky. This is by far the most important one that you need to know. Less than. Less than means subtract, but it also means switch the order. So if it says like 76 less than Q, you switch the order to turnaround phrase. So what students often like to do is 76 less than Q, and that's incorrect. You need to switch them around. 76 less than Q. You might hear me say um, less than flips it. You may hear me say send 76 to the end. It just kind of switches the order. So it's 76 taken away from or subtracted from. Subtracted from and less than are turnaround words that you should know. Going back to this example, 19 more than is addition, 19 more than R. They told us what the variable is, in this case R, so I should write that. Multiplication words, times, product, each of, factors. Product is the one we mess up, but more importantly, with division, we mess up quotient. A lot of students see quotient and they write multiplication. It's not multiplication. Let's go through these examples a little bit, and I can show you how we should be doing these. This third example that we're up to, a number, which we'll call F, increased by 20. Sometimes students say, oh, the number, I'll call that W, and the number is no. They're telling you your number is titled, is called F. So instead of writing two variables, the variable they're telling you should be F, decreased by 20. The next example, I see the word is, I should immediately write that down. 3,505 is a number, which they're calling S, increased by 900. S increased by 900. Let's see, is there an is? No, but there's the word equals. Equals 45, so it's an equation. 6 times a number, which they're calling y. 6 times a number, which they're calling y. And 3 equals 45. There's that word is again. 86 is the sum means addition. So the sum of 9 times the number of tickets and 5. So we're adding 5 plus 9 times the number of tickets. This and this are being added. So how can I write 9 times the number of tickets? Well, times is multiplication. And this time they didn't tell us what the variable is called. They're giving us the freedom to name my variable. I could put T, but T is confusing. So I'm going to use N. So 9 times N, because T looks like a plus sign. I don't want to get messed up. Last example, I don't see the word is, so it's probably just an expression. Mark's salary plus 200. Super easy example, but we want to talk about it because, once again, they did not give us a definition for the variable, so we can choose, I'm going to do M for Mark's salary plus 200.